The topic is derivation of parallel plate capacitor capacity. This question we got number of times in the annual examination for 4 marks. So that all of you listen this carefully. After that I will give the time to you and record that clearly. See that. Now we want to take parallel plates. One plate is M, another plate is N. In a capacitor, compulsory this plate is a charged plate, it is an uncharged plate, outside is connected to earth. So here totally positive charges and in this side totally negative charges are deposited. Distance between the plates is D and we will get the uniform electric field. Okay, now consider capital A area of parallel plate capacitor Mn. Now this plate area is same, means area is capital A. Consider capital A area of parallel plate capacitor Mn. Distance between the plates is D. We know that between the plates what is formed? Uniform electric field is formed. But this is a plate. Plate means metal. Now you take, this is a charged plate. This is a charged plate. Nearer to that what we can get? Electric field is present. Nearer to a charged plate, the intensity of electric field equation is derived in the 4th chapter under Gauss theorem as E is equal to sigma by epsilon naught. What is the E is equal to sigma by epsilon naught? This is the electric field strength, otherwise intensity of electric field by a charged plate. How much? What is the mathematical expression for intensity of electric field by a charged plate? Otherwise the electric field strength by a charged plate with the help of the Gauss theorem we are proved in the previous chapter. You must be remember that equation to solve the parallel plate capacitor. Okay. Electric field strength by the plate M is equal to how much? Sigma by epsilon naught. What is a sigma? Sigma is called surface charge density. Sigma is called surface charge density, means surface charge density sigma is equal to charge per area. So instead of sigma what we can take? Q by A. What is a sigma? Sigma is called surface charge density. What is a sigma? Surface charge density. This surface charge density sigma is equal Q by A. This we are proved in the previous chapter. Okay, so instead of sigma what we can write? Q by A. And we know that in this chapter we are derived the relation between E comma V. What is that one? E is equal to V by D. This is a scalar form, but in the derivation we proved that V is equal to E by R, but here distance is not R, distance is here, it is D. That's why E is equal to V by D. So what is the E? Q by A epsilon naught, V by D, cross multiplication. So what we can get? Q into D by A epsilon naught. As per the definition, what is the mathematical form for capacity? C is equal to Q by V. At the place of V you write this value q into d by, at the place of v, q into d by a epsilon naught, q cancel. So what we can get? C is equal to a epsilon naught by d. This is the mathematical form for parallel plate, capacitor, capacity. What is the mathematical expression for the parallel plate, capacitor, capacity? C is equal to a epsilon naught by d. What is the A? Area of the plate. What is the D? Distance between the plates. But we can write another equation at last. A is equal to pi r square. Pi r square is the formula of the which one? Area of the circle. If the plates are circular plates, instead of A, what we can write? Pi r square. So what is a parallel plate, capacitor, capacity? C is equal to A epsilon naught by D. Now let us see, this is the equation. From this equation we can notice the 2 points. Capacitor capacity is increases when the area is increases. Area is more, capacity is more. Otherwise distance is decreases, the capacity is increases. In the definition of capacity, what we can say? Capacity is increases by reducing the potential. Potential is reduces, capacity is increases. But here means in the parallel plate capacitor capacity, the capacity is depends on 2 factors from this equation. First depends on which one? Area. Second depends on distance between the plates. Distance between the plates. When the area is increases, capacity is increases. When the area decreases, capacity is decreases. So which relation is there? Proportional relation is there. What is the relation? C proportional to A. Now between C and D, it is which relation? Inverse relation. Okay, means when area increases, capacity is increases. When the distance between the plates is decreases, the capacity is increases. Okay, based on this we have 2 marks question also in our book, textbook. Area is doubled, what about the capacity? Area is doubled, capacity is also doubled. If the distance is halved, what about the capacity? Capacity is also doubled. Why? Inverse relation is there. Okay, and this is the principle for the parallel plate, capacitor, capacity. And to solve this, we should remember one point, that is electric field strength by plate, that is E is equal to sigma by epsilon naught. This proof we are studied in the previous chapter. Previous chapter means electric charges and electric fields chapter. Under Gauss theorem we are proved that the intensity of electric field or strength of electric field as E is equal to sigma by epsilon naught. You remember that equation, and then it is very easy to solve the derivation of parallel plate, capacitor, capacity. Okay, all of you record this neatly. That's why I am not moving on the screen.